Am I
The
audible?
yes. Participant are now joining. So let us give just couple of minutes to them. So one good number of quantity will be there.
Okay, okay.
Within just 2-3 minutes, most of them can be join us. So that's why I am waiting just. Sir, can we start? Gandhi sir?
Yes, yes, we can.
Okay. Sir, please switch on your camera.
Actually, I have switch on, but I don't know whether you are getting my
Yes, I am
screen or
not.
not.
No, screen is busy. Screen is there, but it is blank white screen.
Automatically, actually, it is switching off.
Okay, let me see from
Please
here.
check at your end. Are you getting my screen? Am
I'm
I?
getting your voice, sir. Now just
Okay.
switch on your
I have
camera
switched
again.
on my camera actually.
Okay. Huh? Sir, once just you leave for a couple of seconds and rejoin you.
Okay. Should I leave and rejoin again in a meeting?
Yes.
Okay. Sir, your voice is not audible.
Yes. Now
Okay,
I
okay.
think it is audible. एक मिनट. Okay. So uh, Very good evening, one and all. Uh, Respected speaker, Dr. Anish Kumar Gandhi, and other participant. Uh, Today is our third day, and this one is the first session of our third day. It is my pleasure to introduce Dr. Anish Gandhi. Anish Gandhi is holding the PhD Mechanical from SVNIT Surat. He is also heading the MBA in marketing as well as the post graduation diploma in intellectual property rights. He has a more than 3 decades experience in academics, research, as well as the industry. He is a registered patent agent of India. He is also a valuer of plant and machinery under IBBI. He is a fellow of Institute of Engineers and Chartered Engineers too. He has guided several PhD students as well as postgraduate students. He has published more than 65 publications in international journal. He has written some books also. In his account, he has patent as well as the design registration also. He is a regular consultant for various industrial projects. With this short introduction of Dr. Anish Gandhi, I am handovering to Dr. Gandhi. So, Dr. Gandhi, please you take over the session. Thank you very much.
Okay. Thank you, Taylor sir. I welcome all the participants here again. And let us share my screen. I hope my screen is visible to you.
Yes, sir.
Okay. Okay, so I hope my screen is visible to all of you.
Yes, sir.
Okay, okay. So just in line with the theme of the 1 week faculty development program, which is related to the development in micro nano machining in context of industry 4.0. I'll be delivering today content entitled Protecting Technological Innovations in Context of Industry 4.0. So basically, in this particular case, I am going to cover, first of all, introduction to Industry 4.0. We will also have a little bit discussion on how the industry has transformed from its first version to the fourth version. Then there is one case of the digital enterprise. We will try to have some small video, which is from the very well-known industry. Then we will have some discussion on Industry 4.0 in Indian context. Then again, we'll be discussing 3 groups of technologies for Industry 4.0 according to the European Patent Office, EPO. Then we will have Industry 4.0 global statistics. So why we are discussing all this? With this discussion, we'll be able to understand what are the elements or main elements when we look at the Industry 4.0. And also we will just discuss that how the particular element can be protected using the intellectual property rights. We will not have much detailed discussion on intellectual property rights, but of course, which are the elements and how it is to be protected and what are the challenges, that will be the you can say the end part of our discussion. Then we will also have a what are the new challenges in IP system, as already I have discussed, and innovation policy in digital era. And I've also list some of the references. So already you are going through this faculty development program. So all of you might have come across Introduction to Industry 4.0. So it is also known as a fourth industrial revolution, or also abbreviated as Industry 4.0, shortly as I 4.0. It is bringing together the different silos in the production system. Okay, so now we are talking about, as we are talking about the manufacturing here, nanotechnology and micro machinings and manufacturings, we are talking about say production systems. So when we look at the production systems, it is via a network, then allowing the real-time sharing. Basically, it is a data sharing. So real-time data sharing. And the most important part, say why we are in need of network which allows the data sharing, which is in a real time. Again, what we want is to facilitate machine to machine, means one machine to another machine, or one machine to the group of machines, or maybe group of machine to the one machine, and a human to machine interactions. And that is again at unprecedented speed and scale. So we have to also focus on there should not be any lag of the time when we look at this machine to machine or a human to machine interactions. And again, we are also talking about a large scale. So when I'll be just discussing with you one of the case, okay, at that time we will understand that what can be the scale of this. This is giving rise to the seamlessly integrated value chain with interconnected. So again, there are two words which we are discussing here, which are very important as far as Industry 4.0 is concerned. We are talking about interconnected cyber and physical system. So today we are talking about IoT. So when we look at IoT, it is nothing but a cyber and physical system. So it is an interconnection of cyber and physical system, which enabling decentralized decision making and again unprecedented level of the automation. So here more emphasis on the automation basically, and that is through interconnected cyber and physical systems. So now the digitalization of the entire manufacturing value chain, starting from procurement of raw material and extending right up to customer service using mobile devices, communication network, sensors and actuator, is completely transforming how the world factories operate. So this is very important. Again, the things will be clear when we are just have a discussion on one of the case. So today we are talking about a digitalization. And if you look at the digitalization of a entire manufacturing value chain. Entire chain means we are talking about on the downward or backward integration side, starting from the raw material, and on the forward integration side, we are talking about the end customers. So again, with various elements involving various elements such as mobile devices, communication network, sensor, actuators. Okay, and this is completely transforming how the world factories are operating now. So now when we look at adoption of Industry 4.0 and its benefits to the manufacturers, So the first and very foremost benefit, what we look at as cost reduction and efficiency. So this is entitled under, or say titled under, cost reduction and efficiency. So cyber physical system can monitor the factory processes and make decentralized decision, enabling the faster processing. So now when we try to understand this particular point, as we can discuss here, a connected factory is capable of taking automated self-corrective measure in the instance of error. So we are talking about basically adaptive type of technology. Adaptive type of technology means which adapt to the situation, just like a human being. So if there are some errors which may happen, immediately the system itself react to that and take some corrective actions. So this is what we call it as an adaptation in a real time. Then technologies such as 3D printing and laser technology. So 3D printing is, of course, nowadays a very important, and it is going to altogether the change the world, the change the way in which, okay, we are walking in the field of manufacturing. So technology such as 3D printing and laser technology allow the better utilization of the resources such as soft floor, and thereby adding to the operational efficiencies. So again, I'll not be going into detail of the 3D printing and laser technology, but this is nowadays widely used, and with a further technological development and better technologies available in the form of 3D printing and laser technology. Okay, lot of manufacturing units are utilizing this technology, resulting into saving in terms of resources like a soft floor, thereby adding the operational efficiency. Because when we look at a physical space, that is the most important bottleneck in any of the manufacturing atmosphere. So space utilization is very important here. Now this leads to cost saving, better productivity, faster time to market. So we know that earlier to go for a prototype was taking maybe a longer time or a larger time, but with the 3D printing technologies, it has become quite easy. There are many cases. Now another advantage is a value addition. So digital manufacturing technology such as 3D printing, laser cutting, CNC milling, robotic assembly. So again, I'm adding two more feature. We are also talking about the CNC machines. It is not a milling only, but CNC machines. And another very important aspect of 4.0 is a robotics, field of robotics. So various digital manufacturing technologies such as 3D printing, laser cutting, CNC technologies, and robotic assembly. This allow manufacturing of the product in a small batches, thereby allowing for a better customization, quality, and value addition. See, we have already come across batch production, project type of things, mass production. So when we look at the batch production, why the batch production is important? So there are the cases where machine required some setup time. And if you, after investing on a setup time, if you go for manufacturing of only a single product, it will not be, you can say, the feasible. But nowadays with the digital manufacturing technologies, even you can go for only one product, okay, without involving much cost. So here we are talking about flexibility basically. So today's machines are quite flexible, and you can easily change from one product to the next product. Another aspect is a health and safety of the factory workers. So by eliminating the need for human presence, okay, we are coming across a soft floor which are manless. Okay, no human beings are available on a soft floor except in a control room, except for maintenance purpose as and when it is required, or some malfunction or some error happens. So by eliminating the need for human presence and intervention in the certain high risk task. Okay. Now, when we look at high risk tasks, so what it involves? Say there are certain work environments where human cannot perform the task directly. As an example, we are talking about a nuclear power plants. Okay, where there are some radiations, or there are areas where some radiations are there, and there it has to be operated, or some maintenance is to be done. We are talking about performance of certain tasks which are underwater. So again, or we are talking about some industries or a software where which is prone to the environment, which is say harmful to the humans, or there are certain environments which is quietly high temperature. So by eliminating the need for a human presence or intervention in a certain high risk task and environment, industry 4.0 can help manufacturer avoid exposing worker to the health hazard and reduce the fatalities on the factory floor. So now very briefly, we'll look at the transformation from industry 1.0 to the 4.0 under the title of the rise of connected ecosystem. So these are two well-known photographs which I have again taken from the certain web sources. So the first industrial revolution, if you look at it, goes time back to 1760 to 1830. It has witnessed the exponential growth of machinery, mechanization in the production with the help of water and steam power initially. Before the first industrial revolution, manufacturing was done with simple tool, and there were unskilled workers who worked under the unbearable conditions. So this is before the industrial revolution, and in the first revolution, basically the water and the steam power was used, mechanization was there, there were the growth of the different types of machinery. In the second industrial revolution, which goes back to the 1870 to 1969, it has witnessed electric power generator, which has replaced water and steam power engines. Then a large scale production, large factories such as steel revolution in the manufacturing factories, advent of the assembly line and electric power revolution, telephone, as well as refrigerator and washing machine. So these all has been introduced during the second revolution. In the photograph, you can see this. This is an assembly line of uh, automobile industry, and you can see here the first telephone. Then a third industrial revolution where we are talking about say 18 say automating production and information technology. So automation and information technology has been introduced here. It comes with the enormous changes in the industries with a digitalization that transform manufacturing and automation. So digitalization has done a lot of changes in the field of manufacturing. This period witnessed exponential technological changes like 3D printing, big data, modern technology in mechanical devices instead of analog electronics. So we have gone from analog to the digital electronics, and that is also the, you can say, the result of the third industrial revolution. In the fourth industrial revolution or industry 4.0, it is witnessing drastic and exponential change that is transforming how people working with a devices like computer to electronic devices working and helping human beings. Okay, so now there is an interaction. The fourth industrial is a continuation of the third industrial revolution that was categorized with digitalization and automation and manufacturing. So basically we can say it is advancement of the third industrial revolution only, where digitalization was already introduced, automation was already introduced. So now again, this is one chart which is just talking about complexity versus development of the technology. Year-wise, some scaling has been given, starting from first industrial revolution to the fourth industrial revolution. Here, if we look at, I want to emphasize on the lower part of this particular chart. In the first revolution, we are talking about mechanical assemblies. In the second revolution, we are talking about mechanical assemblies as well as the electronics. In the third industrial revolution, IT, automation and controls, electronics, mechanical assemblies. And in fourth revolution, we are talking about embedded and connected IT with interaction with the physical system, IT and automation control, electronics and mechanical assemblies. So this clearly gives the introduction to the various elements which has been introduced into the particular industrial 4.0 era. So now the fourth industrial revolution is a cyber physical system characterized by a physical, digital and biological sphere which is transforming and impacting all work of life, including economics and industries. So it has impact on all the spheres of a life, you can say. It is witnessing the growth of 3D printing, certain technologies like 3D printing, artificial intelligence, smart robot and automation, quantum computing. Lot of work is going on in the field of quantum computing, Internet of Things, drone technology has emerged like anything. Blockchain, now it is widely being used. Use of big data. And another important part, what we have not purposely discussed here, and that is an intellectual property. So now Industry 4.0, the key technology levers when we look at, it is an Internet of Things. So this allows or enables, IoT enables real-time machine-to-machine interaction by connecting them over a network and help to establish a connected value chain. Another is a big data analytics. So data analytic capabilities to support the intelligent and real-time decision making. Then cloud computing. So cloud computing offers a platform equipped with vast computational storage and networking capabilities, which would facilitate the interaction among the various technologies. Additive manufacturing. Additive manufacturing helps the production in a small batches in a cost and time effective way by reducing the lead time from product designing to the product release and improve the customization. Augmented reality. So AR could enhance the business operations by leveraging mathematical modeling, AI and virtual reality. So when we look at augmented reality, it also comes with virtual reality. Then cyber security. So cyber security helps establish secured communication protocols to ensure the data security, which is again a very important when we look at the industry 4.0. Robotics, it is an interconnected robots to facilitate automation of the manufacturing processes, helping to improve the efficiency. Then we are talking about M2M, which means machine to machine, involves the use of industrial instrumentation and sensors to record and communicate data directly with the software. So now, if we look at, I am going to just run over here one of the example, okay, which is already available on a web. So I am just opening this link. It seems there is some connectivity issues. Just a minute, I am just running one video which is of most important for us. Okay. So here, this is the title is a sustainable digital enterprise. So in this, you have seen that uh, basically combining the digital world with a manufacturing, not only the manufacturing, but you have seen that they try to emphasize on a different manufacturing industry, starting from the uh, chemical plant to the certain, you can say the medical implant manufacturing and other aspects. So if you look at here, the Siemens, as we all know, that it is doing a fantastic job as far as this particular area is concerned. But my purpose was to just give you as an overall what Industry 4.0 means. So even I appeal all of you to visit the website of this Siemens, where you can just go through the various solutions what they are offering. So with that we can understand that how the Industry 4.0 is impacting. So now if we look at the Industry 4.0, India Inc. is also gearing up for a change. Globally, the Industry 4.0 market is expected to reach US dollar 190.85 billion in 2025 itself. Countries such as USA, China, Japan, and European nations such as UK, Ireland, Sweden, and Austria have all started adopting Industry 4.0. You can say that these are the leaders who are working in this particular field. In India, the fifth largest manufacturing country, as we can say today, the manufacturing sector forms an integral part of the country's long-term vision, as seen by the government's strong focus on the Make in India campaign. The government aims to augment the share of manufacturing in the GDP to the 25%. Presently, this is 17%. A number of initiatives and policy reforms, such as implementation of goods and service tax, foreign direct policy easing, then it has taken by the government, and many other steps has been taken by the government, which are the policy steps to achieve this particular target. Now, some of the notable steps which are taken by the automotive manufacturing, this is again one example. Suppose if we talk about the automotive manufacturers, so this will give the example, okay, adoption of Industry 4.0 by the automotive industry. So when we look at here the technology, so on a large scale, they are using now cobots. So that is known as a collaborative robots, 3D printing technologies. So example I have added here, one of the largest manufacturer of the two-wheeler in the India has installed cobots at its plant to automate the assembly lines. Several processes such as material handling, welding, deburring, bolt tightening, sealant application, and machine tending were collaboratively handled by cobots and the plant employees. It has led to the benefit such as enhancement in the productivity for the company. The production rose from 507 vehicle per person per year to 804 units per person per year while maintaining the existing standard. Another was, say, 3D printing technology. The largest two-wheeler manufacturer of the India is using the additive manufacturing for product designing of all two-wheeler parts for fitment and functional testing. So we are talking about here the prototype manufacturing. So widely the 3D printing has been used for the purpose, and this has helped the company to reduce the time to market. Otherwise, earlier it was taking a lot of time from the first inception or just the idea to the market. But now, because of this technology, even development process time has been reduced drastically. The cost has been reduced drastically. You can see here that two-wheeler, I have put up here the logo. This is by the Bajaj. So now again, this is one photograph of one of the plant of the Bajaj, where you can say that uh, various workers are there and they are using a lot of automated technologies. So you can say that there is a human to machine interactions. Other sectors speeding up to adopt the Industry 4.0 includes the textile. So example is an intelligent plant framework, A Mumbai-based multinational company uses intelligent plant framework to connect all machines and examine the rate of work and the efficiency. The framework allows to reduce the wastage and organize the production flow. Packaging connected machines. A Bangalore-based packaging company has connected machines over the network that provide a monthly dashboard about the machine. It helps the company put predictive maintenance in place. This slide talks about various steps which are taken by the government of India to promote adoption of the Industry 4.0. So, National Manufacturing Policy 2017, it has already started. The government rolled out a new policy to push the manufacturing share to 25% of the GDP by consolidating Make in India initiative with the focus on adoption of digital platform for I 4.0. Actually, the target was it is to be done up to 2022, but still today also the manufacturing percentage as a percentage of contribution of the manufacturing to the GDP is 17% only. Though various steps are taken, this figure shows that it has not improved. But of course, government has taken a lot of initiative, a national program on the artificial intelligence. So in the union budget itself, it was started to 2018-19, it was started. The government announced that the Niti Aayog will create a roadmap for national AI program focusing on developing new AI applications. Nowadays, we see that a lot of new institute has been emerged, which completely focusing on the education and training only related to the area of the AI. New courses has been introduced. So Center of Excellence in the IT for Industry 4.0. Okay, this COE would act as a knowledge center for entrepreneurs and startups propagating the concept of IT and its application in Industry 4.0. Mission on cyber physical system. So as per again Union Budget 2018-19. See, I have put up there. From there, you can say the initiatives has already been started. The Department of Science and Technology has decided to launch a CPS mission to support, that is a cyber physical system mission to support establishment of CAE for training in robotic, AI, digital manufacturing, etc. And nowadays you can see that in many institute of national reputation like IITs, NITs, and even in certain private institutions also, you can see that such a type of center of excellence are already being established and many of the student and the industry people have been trained. So now when we look at what are the skills required when we look at the industry 4.0, so digital knowledge and ability to work with a data. So this is the most important. And because of that, in a data analytics, data mining, lot of courses have been introduced. So ability to use the automated system, knowledge of a new age technology such as IoT, AR, VR, machine learning, big data analytics, knowledge of cyber security and data protection, statistical knowledge and ability to analyze the data generated from machines. Then cross-functional expertise are also required, like understanding of the cross-functional processes, focus on the client need and industry trend, expertise in working under ambiguous and challenging environment or a changing environment even. Then soft skills such as collaboration, emotional intelligence, decision making and upskilling. Earlier people were not talking about emotional intelligence, but nowadays it has been given a lot of importance. So digital skills and cross domain expertise are likely to become game changer in the industry 4.0 era. Nowadays we can say that instead of knowledge only in the core field like a mechanical engineering or a civil engineering or only the computer engineering, what is important is a interdisciplinary functions. So that can be achieved either building a good team with a mix of a people, but that is again not an enough. Even mechanical engineer needs to learn certain technologies which is in the field of maybe the AI, maybe the digital manufacturing, maybe the data. Okay, in order to say become successful, and in order to contribute to the further development. So now the role of government, industry and academia. So government take the job creation initiative like Make in India. Okay, again it is of 2022, but Make in India was started uh, even you can say somewhere around 2017-18. Involve the private sector in PPP models. Already many institutions are now run in a PPP mode. Many research institutions are there in a PPP mode. Launch mass skilling initiative, create proper infrastructure and develop the innovation centers. Okay, at many states, we are talking about the innovation centers. Okay, in Gujarat also, iHub. Okay, it is performing a pivotal role when we look at this particular aspect. Provide supportive policies, adequate financing for skill development, promote a practical and industry oriented training, improve quality of academic institution and vocational training. So again, government has made it compulsory to have certain certification, okay, like maybe the accreditation and other things. So again, that was the point, was to improve the quality of the academic institutions. Then industry. So create and define the new roles, which is very important. Industry has to define that what are the requirements when we look at the era of industry 4.0. If they're able to define the requirement, then only the appropriate steps can be taken to understand that what are the skill base which is required in a manpower. Then provide a reskilling opportunities. Then provide the cross-functional exposure to the employees, which is very important. Establish leadership 4.0, which fosters the culture of upskilling. See, nowadays the days has gone like if one person is entering in a job and by doing the same type of work in a same manner, they get retired after the 30 or 35 years. Nowadays, even each and every employee, whether it is in a government or a private sector, needs to keep on learning new and new areas. Then only, okay, they will be able to perform their own task. Otherwise, it will not be possible even for an industry to retain them. So again, we are talking about the academia. Okay, I'll not, of course, a lot of curriculum development has been done, changes in the syllabus has been taken up, new courses has been added, and a lot of things has been done as far as this particular thing is concerned. Now, three groups of technologies for Industry 4.0 according to the EPU. So now here we are going to talk about how Industry 4.0, okay, we have understood that government, what government is doing, what new things has been done, what initiatives has been taken. We also try to discuss that. Now we are going to talk about what is the role of IP and why IP is important, and which areas when we talk about will come across when we'll talk about the industry 4.0, which needs the protection. So when we look at it, is defined by European Patent Office, EPO. So core technologies embodied in the connected objects like hardware. Okay, hardware maybe, as an example, I have written here sensor. It is not only the sensor which is a hardware. Then software, as an example, adaptive databases, intelligent data storage, connectivity, network protocol for connected devices, enabling technologies. So we are talking about core technologies. Then enabling technologies like AI, 3D printing, adaptive security systems, etc. Application domains like smart manufacturing, smart home, smart city, etc. etc. A lot of things has been done. We have come across a lot of examples which have already been implemented in a field when we look at the smart manufacturing, smart home, okay, smart cities, etc. So these are the core areas which is defined by, so it is a mix of what we call it as software and hardware. Okay, nowadays it is difficult to come up with any hardware, okay, which runs without the software, without the algorithm. Industry 4.0, if we look at the global statistics, okay, now why these are important? So when we are looking at the technologies, okay, whether it is in the form of any physical product, whether it is in the form of methodologies of doing something, okay, so when it falls under all these areas, it can be considered that it is relevant from the industry 4.0 perspective. And once you do that, then again important part is how to protect it. Then industry 4.0 global statistics, if you look at, okay, so the number of patent application in technologies related to industry 4.0 began to rise in mid 1990s, increasing from around 300 in 1995 to 944 in 2000 and to 5500 in 2016. See, nowadays only related to industry 4.0 a specific statistics is not available. Again, when we look at AI, so nowadays data are available that how the AI related patent applications has been reported in terms of a statistics. Again, AI can be considered as a one part of industry 4.0 itself. In 2016, there were almost twice as many patent applications in industry 4.0 in 2011. So this was again, you can see that drastic rise was there. The share of all applications of EPO is small. In 2016, they constitute 3.3% of European patent application, but grow to 1% in from 1% in 1990. So European Patent Office has given this data. It was related to the EPO. As far as India is concerned, a very specific data related to that, it is difficult to get it. Invention in Industry 4.0 technology at EPO have been dominated by USA, Europe, and Japan. Now, when we look at European Patent Office, basically it is serving for all the countries of a European Union. The increase in the patent applications in Industry 4.0 is driven by limited number of applications. In 2011 to 16, a group of 25 applications accounted for 48% of application in Industry 4.0 filed by APO. I am not focusing much on that. Okay, these are some of the say data which has been given that out of 25 applicants at the EPO in Industry 4.0 who has say played a dominant role when it was just initiated somewhere around 2016 around. So 12 Asian companies, 7 were from Japan, like Sony, Panasonic, 3 from China. Okay, certain examples are Huawei and Koen. Then 2 from Korea, Samsung, LG. So they have played a dominant role. 7 from US, like Qualcomm, Intel, Google. 5 from Europe, named as Nokia and others. 1 from Canada, so BlackBerry Limited. So these companies has played a dominant role as far as say Industry 4.0 is concerned. Not only that, protecting their inventions related to 4.0 is concerned. About 30% of patent applications come from inventions from Europe as far as Industry 4.0 is concerned. In Europe, there is a strong geographical concentration of Industry 4.0 patent. Germany is the leader in Europe, followed by France and the United Kingdom, followed by Sweden, Finland, Netherlands, Switzerland. So if you try to search for a patent, if you try to search country wise, okay, from these countries, you will be able to cover a large portion of the patents which has been filed in Industry 4.0. In core technologies of Industry 4.0, European countries are the strongest in connectivity. and the weakest in hardware. So we are talking about the data, we are talking about the hardware part also. So these are the companies where these codes are given as per the WIPO, say code names. So basically, this is Germany, France, UK, etc. Even I need to just work on this, that what it is for. Then enabling technologies, Europe is the quite strong in artificial intelligence. Again, European Union countries are given here. This is basically Finland actually. Uh, and the security, but has a relative lower position in the energy supply. In application domains, European countries rank highly for inventions in vehicles and infrastructures. So now, why protecting innovation through the patent? Okay, so we have discussed little bit about the statistics. Of course, India is quite far, you can say, out of this data, because even big four countries who are filing the patents, big five countries who are filing the patents, they are different. So as you cannot match the number still, okay, we can say that if you try to work on a statistics at a global level, India rank may be quite below. Why protecting innovation through the patent? To benefit those who have knowledge and inventive power. So it is always better to protect our invention, okay, in order to get the benefits. Benefits are in two things, like one is to recover the cost and resources, okay, what you have invested in development. Not only that, even to get a reasonable, to get an opportunity to earn the profit reasonably because of your intellectual involvement, okay, and that will give lot of push, lot of incentive it will give you to again come up with a further innovations, to increase the cost of access to those without the knowledge and inventive power by limiting the use of innovation monopoly. So now here, uh, when we look at how is digital revolution changing the role of patent in protecting innovation. So when we look at here, we are focusing on the digital divide, a different innovation modes, innovation versus imitation, diffusion. So these are some of the important words, okay, which uh, comes into the picture when we are discussing the field of intellectual property right here. I'll not be discussing much on this. In fast developing digital industries, protection of the innovative solution has been changing. Innovators might not be interested in protecting new solutions through the patent. Okay, now look at this sentence. This is very important. Those who knows the process of filing of the patent, prosecution at the patent offices and getting the grant. So it takes a lot of time. Earlier it was 7 years, average period of 7 years was there at Indian Patent Office. In last 5 years, they have done a lot of work, lot of recruitment has been done, policy changes has been done at the patent office, supported by the infrastructure, and now they are targeting on an average time of 3 years. But when we look at certain fast changing technologies, even that 2 to 3 years is also the very high period of time you can say for them. By the time the patent will be granted, may be possible the technology itself gets obsolete and something new has already arrived. And when we look at the fast changing technology, for those technologies, if the life cycle is, when we say fast changing means life cycle time itself is very small, 3 years, 5 years at the most, like that. Under the circumstances, if you maintain certain level of secrecy, definitely you will be able to sustain your, you can say, the revenue within that time, and it will be difficult to maybe target your technology and come up with the copy of your product, okay, by the competitor. But of course, it has been said that in China, they have a great capabilities, even when we look at the copy. I came across one case where it has been reported that if you give one iPhone to the China, they are able to come up with the same copy of that iPhone within 14 days. And not only the prototype, they it has been said that they have a capability to make it ready for market just within 14 days from the time when it was given or when it will be given to them. So this is how they have developed the capability. So even though the product life cycle has reduces, even you can say the reverse engineering time and all these things have also been reduced. So that will also remains always a threat. This is the reason where a countries like Australia has come up with one different type of patent and they call it as a innovation patent. So once you file the patent application, they will publish and they will give you the certificate of grant. But this is the certificate of grant which is given without any examination. Why they have done it? It is just to reduce that grant period. But then it is allotted only for 8 years. Normally, for patent, which is known as a utility patent, even in Australia, in India, it is known as a patent. Okay, the time, say, life of the patent is a 20 years everywhere. Okay, it is as per the or it is followed by the WTO guideline. But this is a new category of a patent called innovation patent. They are allowing the lifetime of only 8 years for this type of patents. But that is only the certificate of grant. Though the certificate of grant is there, you cannot impose your right. If somebody is copying and you want to impose your right, then you have to apply for the examination and it will be formally examined and then certificate of registration will be given. So I have seen that in order to even where the point for filing of the patent and grant of the patent is important. I have seen many Indian people started filing the innovation patent in Australia because they are getting the grant certificate. But it has no meaning, it has no value at all when it comes to the imposing your rights. So that needs to be understood. It is just like publication of patent in India. Though there is a grant certificate, it is equivalent to just publication of patent in India or any other country. Now, protection of a digital innovation might not be possible. Okay, like big data use, computer programs. At as per the WTO guideline, if you look at the computer programs, okay, these are coming under or categorized under the abstract idea, and it is not patentable. So even in India, Section 3K says that computer programs are not patentable. However, it can be protected under the copyrights. But it has been said now because as we have seen, that you will not come across any technology now, okay, which do not involve any type of algorithm or the program for its working, for its functioning. So computer program has become a very important element, and because of that, many times your product has a value. So then how to protect? So again, now every time government is also thinking and coming up with a new and new policies. So now it has been said that computer program per se word has been added. It is not patentable. Again, the new guideline has been introduced by the government of India. It is a draft guideline yet to be finalized in just this March 2025, which you can refer through the Patent Office website of Government of India only, where they have given some guideline related to the examination of the computer related invention, in which they have also introduced AI related inventions. So diffusions and imitation of the innovation is faster than before. So as I was discussing here, with the technological development, even now it has become easy, okay, to imitate other technology, other product, other processes, okay, to go for characterization of the formulations. very accurately and within a short space of time when we look at the certain medicines or some other chemical formulations. It is also possible. So now, what are the new challenges to IP system and innovation policy in the digital era? So this is most important point. The all-encompassing and rapid transition to the digital environments are related to. All of you will be agree with this. We are talking about nowadays artificial intelligence a lot, robotics a lot, big data, 3D printing technology, Internet of Things, Industry Revolution 4.0. I will say that even 4.0 involves all these elements. So what are the new challenges to the IP system and innovation policy? So patents, okay, then brands and designs, copyright and related right, IP economics, that is intellectual property economics, intellectual property law and rule, intellectual property enforcement, and intellectual property office administrations. So when we look at all these different area, okay, let us look at what are the challenges from the patent point of view. So challenges in the phase of transition to the digital environment, it is worth considering how the patent system might impact advances in AI. See, basically, patents are granted to the invention, to the creations of a human mind, right? Creations of a mind. This is the definition. But nowadays, we want to add creation of a human mind. No country has considered in their earlier policy that there will be something like a machine mind. Okay, where machine will be creating some new things. So again, today itself, okay, in most of the patent act and law, patents are not granted to the creations of the artificial intelligence purely. So it is worth considering how the patent system might impact advances in AI, but everyone has to look at that how to consider the AI related inventions now, or there is an involvement of AI in developing some technology in the form of a product or a process, then how to give the patent for that particular type of the invention. On the other way, it is worth considering how artificial intelligence might impact the patent system. So claim construction, inventorship. Now this is very important, inventorship. Say, who is known as an inventor? So the person, okay, who has given their involvement in developing those product and processes. So who has given intellectual inputs in developing those product and a process. Now here, the machine itself is creating something new. So who is inventor? Can we name there a machine is an inventor? So answer is no at this moment. Okay, inventors are always a human beings, whereas applicant can be human. Applicant can be a legal entity, or it can be combination of a legal entity and human beings. Legal entity means it can be any company, any organization, government, research institution, university, anything it can be. Now, what are the requirements of the patentability? So it is again to be defined. How you are going to enforce it? Okay, in the field of era, this is also going to change. Then brands we are talking about. So challenges in the face of transition to the digital environment. The new digital technologies alter fundamentally the traditional way brand and design communicate reputation and image value. So we are talking about non-traditional trademark protection. Animated logo is there, suppose. So even if you look at the Indian trademark registry, you can register logo, but it is an animated logo. So logo is there, but it is not a stationary logo. It is in the form of animation. So how to protect? There is no rules which is existing. Brand protection in the domain name system. So again, you may find that reliance.com might have been registered by someone else. Okay, whereas Reliance is a very big brand here in India, as you can see. So there is no system where, okay, brand name may be with someone else and domain name maybe if it is available, you can take it up. use of the brand in the social media. So again, it is quite difficult. Okay, with the, you can say, uh, introduction of the social media, if you are introducing or using, or somebody is using your brand in a social media in a certain way, okay, how to take care of the rights of the originator or rights of the owner, protection of a country name, geographical indications and names of geographical significance against the unauthorized delegation as a domain names. So again, there is some system which is required, okay, where when the domain names are allocated, okay, before allocating that domain name, some checks are performed. Okay, now in terms of a design, new digital technologies impact the design products. See, earlier when we say design protection means designs registrations are done for article of manufacture, means the articles which are existing physically or which can be manufactured, and you can say which are tangible product ultimately at the end. So nowadays it has transitioned from hardware design to the digital interface. Okay, we are coming up with certain design which is just appearing on the computer screen only. Design protection for graphic user interfaces, icons, type of fonts. When we look at all this, okay, where it is to be protected, again it is a big challenge. So copyright and related right, digital technologies have reshaped the way the content is being produced and consumed. See, earlier it was difficult to get a certain content which is existing in the form of story, suppose in some other part of world, say as an example Russia. But now in the digital era, and with such a various different platforms which are available, and the economy, you can say, which has been, or economy is what we call it as a very cheap, you can say, the data availability. Okay, nowadays something which has been created somewhere or which is something available in a certain part of world, it can be easily digitally transformed and can be circulated. So here we are talking about difficulties when we come across in this particular point of time. The global distribution of a creative content is online, on demand, and at a distance. New players and transforming businesses models have emerged both at the national and international level. The advent of AI will further widen the digital divide among the IPOs and IP related institutions. Capacity building for working in digital environment is needed to ensure continuity of knowledge, innovation, and of patent analytic tool for exploitation of this information in developing countries and least developed countries. So these are all the challenges. IPR enforcement, there are some challenges. Online copyright piracy and trademark counterfeiting. Scale is such a large and geographically distributed. So it will be difficult. Suppose I am having some copyright and somebody is using my copyrighted work in the other part of a world. Okay. Suppose in some other country. So how to take action on them, how to impose your right, then exact say exacerbated by the ease, speed, and low cost of making and distributing unauthorized copies online and of engaging in counterfeiting and e-commerce. See, nowadays it is very easy to create something, to distribute it widely within a fraction of time. Difficulties in identifying and or prosecuting the infringers. Cross-border online infringement, this is what I was talking about. Territoriality issue, because all the rights are territorial rights. If you have a granted patent in India, it is limited to India. Okay, though it has been said that once you are creating something, okay, you are getting the rights, say proprietary right all over the world. But then the question comes that how to impose your right if there is someone in the other country who is infringing your rights. Role of intermediaries like internet service providers, etc. Issues specific to developing and least developing countries. Legal framework is a most important point. Many countries do not have their strong legal framework. Capacity constraint, okay, like financial, human, judicial, administrative, technical capabilities. So again, these all depends on uh, the economic condition, then the political conditions of a particular country. IP and judiciary. Judiciary phase with the dispute arising from the innovation in the digital environment, and that outpaces the speed of legislative and regulatory governments. Complex multifaceted disputes requiring effective remedies that reconcile the territory of the IP right and judicial structure with the transitional and online nature of the growing volume of IP disputes. See, now IP filing is increasing, IP awareness is increasing because of the Indian government movements and various sections which they have taken. The day will come as more people have become more about aware about their own IPs and protecting their IPs. Legal disputes are accordingly going to increase drastically over the period of time now. So side by side, government has also to work on how they will be able to cater to the requirement of those increase in the say requirement of judiciaries, involvement of judiciaries to take care of those cases. Concerning novel question arising from the technological changes that may not have been envisaged or addressed by the legislature or the society, involving emerging actors, including online intermediaries, generating increasing volume of cases. Like suppose if I talk about the first case, now already driverless car has started running on the roads in certain country. Now if those cars is doing some accident and there is a loss of life in that particular accident, okay, who will made responsible for this type of cases? Because no human beings are there. It is a driverless car. So it is the owner of that car who is not involved at the time when the car was running, or it is a manufacturer of those car. Okay, because manufacturers after testing giving you the say model, and of course maybe it has not been maintained properly by the owner. This may also happen. Everything may be good. Okay, but the accident may happen, failure may be there because of some of the system which is uh, not able to say, which is not possible to find out that what are the actual reasons because of which it has happened. So a lot of complexities it is creating all over the world. So with this, I just wanted to conclude with my presentation with two messages. Let's generate, protect, protect and enforce the environment, be a part of journey of India from developing country to the developed country by 2047. See, IP is has a very dominant role. All the developed countries, if you look at their IP statistics are quite you can say good in comparison to the developing countries. Let's create shape the world which we have never seen before by new partnership between technology, nature, and humanity. So we are talking about the technology. Okay, we have to talk about along with the technological development, we have to take care of nature and humanity also. Otherwise, in today, okay, very you can say the alarming situations are there all over the world. A lot of disputes are going on between the various countries, and again, how to preserve the nature, that also a big challenges. So whenever we are developing something, we have to look at the nature and the humanity. With this, just with the last message, patent, publish and prosper. If you first publish, it can never be patented, and then prosperity will not be there. So thank you all of you. With this note, I am just stop sharing my presentation.
So thank you, Dr. Anish Gandhi. Thank you very much for your nice talk. And now we are opening the sessions for question answers. Participant, if you have any questions, you can put into the chat box or you can raise your hand. So globally, if you want to get this kind of the property rights, is there any agency or there are also certain segment where in certain European country that already there certain area wise the patenting is possible.
See, as far as patent is concerned, there is nothing like an international patent where you will find only one patent with certain offices. It will be examined, and if it is granted, then you are getting rights all over the world. It is never going to happen. All the patent rights are territorial right. So you have to apply individually to each country.
Okay.
There are two systems which is helping in this particular process. One is a patent cooperation treaty, which is PCT, and another is a convention system of filing. Okay, that is known as a convention application. So how it is helping? So if I have filed the patent application in India, as per the convention patent application, I can file the patent application in other country who are signatory to the Paris Convention within 12 months from the date of filing, preserving my priority of filing in India. So this is one mechanism which has been provided. In a PCT, after filing the priority application in one country, we need to file PCT international application. And once you file PCT international application, it is to be filed within 12 months from the date of initial filing. You have a time frame to enter into other countries individually, 30 or 31 months, depending upon the country.
Okay.
Otherwise, there is some patent offices like one what we call it as a European Patent Office, EPO. So in the EPO, there is one advantage. You just file one patent application with European Patent Office. If it is granted, okay, you can impose your right in all the member countries of a European Union who are signatory to the EPO. But individually, you have to register, and individually, you have to maintain every year by paying the maintenance fee to the various countries. But you need not require to go for individual filing in all European countries. Okay.
Okay.
And with one application, you can have a, if there is a grant, you can impose your right in all the countries.
So it means suppose in one territory when somebody is filing, okay, and then there that informations or the technology whatever it is that will be available in that country territory. Now in a same thing is somebody is fetched there from that territory and if use it in another territory, then what are the legal glitch maybe occurs?
See, like suppose I am having some technology and granted patent in India. And if somebody is, okay, going through my technology, because it is already published also by Indian Patent Office and available to everyone.
Yes.
So if somebody is from the USA, okay, who is referring my published patent, and they started practicing that patent technology in USA. and I have not filed patent in USA. I am not available with the granted patent in USA, so I cannot stop them.
Okay.
But that person cannot produce it in USA and send it to India. It will not be allowed. They cannot produce in India and take it to the USA. It is also not allowed. So when we look at the patent rights, okay, these are the exclusive rights. Okay, you are having a rights to stop all those persons who do not have your consent from the act of selling, making, selling, offering for sale, importing, using the goods without your permission. But otherwise, if you have not protected your technology in the other country, okay, they can do anything with that technology.
So
They will not. It is a
within
territorial right.
okay, so in other territorial they can sell.
Yes, in other territory they can
Suppose
practice.
let us say
They can.
country wise, suppose I have Indian patent.
Yes.
Somebody is using that, making the with that technology in US,
Hmm.
and he can sell in suppose Australia.
Yes, they can. Because in Australia also I don't have a patent.
Apart from the India, they can sell anywhere.
My rights are limited to only India.
India.
If I want in other countries, I should file the patent.
Okay.
And that is the reason I need to properly assess, okay, where I am going to do the business.
Yeah. Means wherever the market is available, there only we have to first.
There you should protect. If there are certain countries who can easily manufacture and copy and start selling, in that country also you should file the patent.
Now, second, what I think that now in industry 4.0, we use now robots also. So if in coming future, the technology may be that kind of nature, which may be like patentable also, where the robots are used, and it means the interfacing may be there with between the human being or some intelligence system.
Hmm.
So for that, still I think rules may not be clear, or that can be come under certain category where it is possible.
No, sir, already related to robotic technology, related to the human robot interaction. Okay, lot of uh, patent applications you will file. You will find already it has been filed, and there is no limitation to that. Challenges are only in the field of AI related inventions, artificial intelligence. Challenges are in the field of when we took a properly, when we look at uh, software or algorithm. Okay, so there are some challenges. So you need to show that some technological effect is there, some say effect is there when we look at the software or an algorithm. It has some interaction with some other system, or it has some technical contribution, or it is solving some technical problem if you are running all those software using some server and some other common infrastructure. So if you are able to do that, definitely even now patents are also granted for that. Otherwise, for robotics and other things, a lot of patents has been filed and granted also. And not only on the robotic technology, but interaction between the robots and the humans, or robots with a machine, or two robots also. Okay, a lot of say technologies are being developed and filed in the form of a patent applications.
Okay. Okay, sir. Thank you very much. Participant, is there any questions? Otherwise, we can end up the session. Let me see in the chat box if anything is there. Okay, sir. There is no any question, further question. So I end up this session with giving you a lot of thanks. Thank you very much, sir.
Okay, okay. Thank you for giving me the opportunity, and really thankful to all the participants who has joined for the program. Topic is little bit technical, maybe boring at some point of time. But of course, we need to understand
Yes,
in terms of how to protect your innovations which are doing in this now, these areas, which are the future.
yes,
Okay,
because
so
without this, the business is not possible.
yes, now without that, business is not possible. Even small offices, if you look at, each and every task are now automized. They are
Yes.
using some platform, even for office administration, work sharing, even for reporting purpose. Even in a small office also, where maybe only two, three, five people are there, they are using this office administration. So world has changed completely, and the way in which India is now fostering to the new technologies and the era, definitely everybody has to adopt, and not only adopt, also has to be a careful in protecting. Otherwise, we may be creating a lot of things, but it will be used by the other people. Okay, if you want to say become a global leader, create the technology, take a right on it, then assign your right to other, authorize the other at your own terms and condition, become rich, earn the money out of it. Maybe if you can earn in terms of a foreign currency, it's quite great. It is going to help a lot in terms of the appreciation of our own currency also. And be a leader, do the white collar job. This is what has been said.
Okay, sir. Thank you very much. So, dear participant, please wait. We can start the second session.
Okay, sir. So now there is a second session. Up to what time it is going to run?
Huh?
There is a second session also after this.
Yes, yes, from 7:30.
Right, right. Okay. Okay, sir. Thank you. Thank you for
Thank you
giving me
very
the
much, sir.
opportunity.
Thank you.
I am leaving this meeting now.
See you, sir.
Thank you.
See you. See you.
Thank
See
you.
you.